Every year, over 1 billion smartphones get made and shipped to people who will immediately drop them face down on concrete. But how does that actually happen? Not the dropping part, the making part. Because your phone is not just a phone, it's the result of one of the most insane global operations ever attempted by human beings. A supply chain so complex that if even one small part of it breaks down, the entire industry feels it. And it starts in the most boring place imaginable. Sand. Yes, sand. The kind you find on a beach, except not exactly that kind. Stick with me. The most important ingredient inside your phone is silicon, and silicon comes from quartz sand. Specifically, a very pure type of quartz sand that gets mined, then refined, then melted down at over 1,400 degrees Celsius until it becomes a single perfect crystal cylinder called an ingot. Think of it like the world's most expensive lollipop that nobody is allowed to eat. That ingot is about the size of a telephone pole, pure silicon, no impurities, and the purity level has to be almost unimaginable. Like we're talking 99.9999999% pure silicon. That's 9 nines. Scientists actually call this 9 nines purity, and achieving it is one of the hardest material science challenges in manufacturing. Once you have your ingot, it gets sliced into wafers, thin, round discs that look like the world's most fragile poker chips. Each wafer is roughly the diameter of a dinner plate and thinner than a human fingernail. These wafers become the foundation for every chip inside your phone. The processor, the memory, the modem, the image signal processor that makes your photos look good, all of it starts here. Now here's where things get genuinely mind-bending. To turn a silicon wafer into a working chip, engineers have to carve billions of transistors onto its surface. Billions! On something smaller than your palm. A transistor is basically just a tiny switch. It's either on or off, 1 or 0. And by combining billions of these switches in very specific patterns, you can do math, store information, run applications, play videos, send messages. Everything your phone does comes down to billions of tiny switches flipping on and off billions of times per second. To put the size into perspective, a human hair is roughly 70 micrometers wide. The transistors in a modern smartphone chip are around 3 nanometers. That means a human hair is about 23,000 times wider than one of these transistors. If your hair were a skyscraper, one of these transistors would be smaller than a marble. That is the level of precision we are dealing with. The process of putting those transistors onto a wafer is called photolithography, and it involves shining extreme ultraviolet light through a stencil called a mask onto the silicon surface. The light changes the chemical properties of whatever it touches, allowing engineers to etch circuits into the wafer layer by layer. Some chips have over 100 layers. The machines that do this cost $150 million each. They weigh as much as a commercial airliner, and there is only one company in the world that makes them, a Dutch company called ASML that most people have never heard of, but that the entire global technology industry completely depends on. This whole chip-making process happens mostly in Taiwan at a company called TSMC, and in South Korea at Samsung's semiconductor division. If you've never heard of TSMC, that's fine, but just know that without them, there is no iPhone, no Android flagship, no laptop, no car with a touch screen, no modern technology as we know it, one company in one country that most people couldn't find on a map, running the whole show. Now the chip is just one ingredient. Your phone contains around 60 different elements from the periodic table. 60. That's more than half of all the naturally occurring elements that exist. Your battery needs cobalt. Most of the world's cobalt comes from the Democratic Republic of Congo. It gets mined, refined, shipped to South Korea or China where it gets turned into battery cells. The battery also needs lithium, which mostly comes from a region called the Lithium Triangle in South America. Chile, Argentina, Bolivia, vast salt flats where lithium-rich brine gets pumped to the surface and left to evaporate in the sun for months before the lithium gets extracted. Then there's tungsten, which helps your phone vibrate when you get a notification. Most of the world's tungsten comes from China. Indium goes into your touchscreen. Tantalum helps capacitors store energy. Rare earth metals with names that sound completely made up like neodymium and praseodymium help produce the colors on your display, and power the tiny speaker that plays your music. Each of these materials has its own supply chain, its own set of mines, its own refineries, its own shipping routes, and all of them have to arrive at the right place at the right time in the right quantity for your phone to exist. If any one of them runs short, the whole thing slows down. We actually saw this happen during the pandemic when a chip shortage caused car manufacturers to halt production because they couldn't get enough semiconductors. The entire automotive industry grinding to a halt because of a component smaller than your fingernail. That's how fragile this system actually is. Before your phone gets assembled, every single component has to be manufactured separately, often in completely different countries. The glass on the front of your phone, almost certainly made by a company called Corning in the United States, they make a product called Gorilla Glass, which is chemically strengthened by being submerged in a hot potassium salt solution that replaces sodium ions in the glass with larger potassium ions, creating a layer of compressive stress on the surface that makes it dramatically harder to scratch or crack. That glass gets shipped to Asia. The camera lens, made in Japan or Germany, using precision optical glass that has to be ground and polished to tolerances measured in nanometers. A single scratch or dust particle during manufacturing can ruin the optical performance of the entire camera system, also shipped to Asia. The display. Your phone screen is almost certainly an OLED display, which works by running electricity through organic compounds that emit light directly. Unlike older LCD screens that need a backlight behind them, OLED pixels produce their own light, which means black pixels can just turn off completely, giving you that deep, true black that OLED screens are famous for. Making an OLED display involves depositing incredibly thin layers of organic material onto a glass substrate in a vacuum chamber. The layers have to be applied with extreme precision. A single layer might be just a few nanometers thick. Samsung Display and LG Display make the vast majority of the world's smartphone OLED panels, including the panels that go into iPhones. Yes, Apple buys its iPhone screens from Samsung, arguably their biggest rival, because nobody else can make them at the required quality and scale. The battery cells, made separately, packaged separately, shipped separately, the antennas, the speaker components, the microphones, the Face ID sensors, the fingerprint readers, all made in different facilities, all shipped to the same destination. Your phone is essentially a global potluck dinner. Except instead of food, everyone brings extremely precise hardware components, and instead of a dinner table, there's a massive factory floor in China or Vietnam or India where it all finally comes together. Final assembly is where most people imagine the whole process happens, but at this point the hard work is mostly done. Assembly is almost the easy part. The factories that assemble smartphones are unlike anything most people have ever seen. Foxconn's facility in Zhengzhou, China, employs over 200,000 workers. It has its own dormitories, its own hospitals, its own fire stations. It's essentially a city that exists for one purpose: to put iPhones together. On the production line, robotic arms and human hands work side by side. Some tasks are still done by humans because human dexterity and judgment in certain assembly steps is still cheaper and more reliable than automating them. Other tasks are done entirely by machines because the precision required is beyond what human hands can consistently achieve. The circuit board gets populated with components first. Tiny chips and resistors and capacitors get placed onto the board by machines that can position thousands of components per hour with sub-millimeter accuracy. The board then passes through a reflow oven that melts solder paste and bonds everything permanently in place. Then the display assembly. The screen gets bonded to the glass cover using optically clear adhesive applied in a vacuum chamber. The vacuum removes any air so no bubbles get trapped between the layers. Get this wrong and you get a screen with a visible gap or distortion. Every single phone. Then the camera modules get installed, the battery gets connected, the housing gets sealed, and then testing begins. Every phone gets tested before it leaves the factory. Not a sample, every single one. Signal tests to make sure the antenna works. Touch tests to make sure every part of the screen responds. Camera tests, speaker tests, microphone tests. Face ID enrollment and verification, water resistance checks. A phone that fails any test gets pulled from the line, diagnosed, either repaired or scrapped. The ones that pass get packaged. A box that also took its own supply chain to produce, by the way, with a manual printed in dozens of languages, with a cable and a charging brick if you're lucky because some companies have decided those are now optional, and then shipped. Before any of this manufacturing starts, before the sand gets melted, before a single mine gets touched, years of work have already happened. Designing a smartphone is an engineering challenge that operates on multiple levels simultaneously. Mechanical engineers are figuring out how to fit all of these components into a body measured in millimeters. Where does the battery go? How do you route the antenna without it interfering with the camera? How do you make room for the haptic engine and the speaker and the microphone and leave space for the structural frame that stops the whole thing from bending in your pocket? Every millimeter matters. Every gram matters. The difference between a phone that feels premium and one that feels cheap often comes down to decisions made at this stage. Electrical engineers are designing the circuit board, figuring out how to connect hundreds of components with copper traces thinner than a human hair without any of them interfering with each other electromagnetically. Your phone is essentially a miniature radio station broadcasting and receiving signals constantly. Getting all of those signals to coexist without interfering with each other is a genuine engineering art form. Thermal engineers are working out how to manage heat. Chips generate heat when they work hard. In a sealed metal and glass box with no fan, that heat has nowhere to go. Engineers use vapor chambers and thermal paste and carefully designed internal structures to spread that heat away from sensitive components. Software engineers are writing the operating system at the same time the hardware is being finalized, which means they're sometimes coding for a chip that hasn't been fully manufactured yet, working from specifications and simulations rather than actual hardware. And then there's testing. Prototype phones get dropped onto steel plates from different heights and angles. They get baked in ovens to simulate extreme heat, frozen to simulate extreme cold, submerged in water, exposed to salt spray, bent, twisted, thrown into bags full of keys and coins, and run through simulated years of use in accelerated testing rigs. All of that before a single consumer ever sees the device. By the time a phone reaches a shelf, it has typically been in development for 2 to 3 years. Hundreds of engineers across multiple continents have worked on it. Thousands of suppliers have contributed components. A global logistics network has moved materials across oceans and borders. The phone in your hand right now is the result of all of that. Sand from the earth turned into chips using machines that cost as much as a jumbo jet, operated by the only company in the world that can build them. Metals pulled from mines on 4 continents, glass strengthened through chemistry developed over decades, displays built atom by atom in vacuum chambers, all of it assembled by human hands and robotic arms in factories the size of small cities, tested individually, packaged, shipped halfway around the world, and it ends up in your pocket for a few $100s. If you stop and actually think about that, it is completely insane. The next time you pull your phone out to check something, remember, it didn't come from a store, it came from everywhere. If you want to go deeper on any part of this, the chip wars between the US and China, the story of TSMC, and why it matters more than most governments want to admit, the mining operations behind your battery, we've got all of it. Stay curious.